Our next presenter is Hartmut Opfermann from QvestMedia, and he is going to be talking about management of audio streams at ORF. And he will also be joined by his co-presenter, Andreas Fraundorfer. And take it away, gentlemen. Thank you.
Thank you.
Okay, so thanks for having us. We will start by just one slide each with our presentations about our companies, just so that you know who we are. Then Andreas will go forward, present the project scope from an ORF point of view. And I will go on and present the solution we offered for this project scope. And then we will dive into a specific part of this project, the requirements for audio signal management that ORF had, and again, the solution we presented, we offered, and designed together with ORF for this these requirements on audio signal management. So with that, I'll hand it over to Andreas for the presentation of ORF.
Thank you. Good afternoon from my side. ORF is a public broadcaster. It's located in Austria and Europe, and the headquarters is in Vienna. And we have about 2,500 employees and about 9 million viewers. We are hosting 4 national TV channels, which are distributed over the air via satellite or DVB-2. And we have 9 regional TV channels. These are also transported via these medias. We also host 1 European TV channel. It's called UF2 Europe on Austria. And in addition to that, we also host some radio programs, which are national-wide reachable, or even 9 regional radio programs. We have an internet platform. And of course, as it is at the moment, it is possible, we can offer you an online on-demand platform, but only restricted to 7 days. At the moment, we have a law that keeps us to have it just 7 days online. Thank you. I hand over to Hartmut.
Okay, QvestMedia is a system integrator and also a technology consulting group. We are more than 9,500 employees in 20 offices around the world, out of 2,300 clients, a lot of high-end projects with our technology and media consultants. And yeah, we also have a part where we develop software with a lot of developers, and especially also user experience and user interface design experts, so we can really handle end-to-end projects, including software development, including business consulting assignments, but also like classical media system integration projects like this one.
Yeah, and then maybe we will go further on to our project. We placed a tender in 2019 with a goal for renovation of our complete technical infrastructure in ORF Center. The goal was to go to IP systems, try to standardize those systems, because in the past we had lots of different systems. And one of the major goals was the replacement of the playout center and the master control room or main control room, and also the installation of a new monitoring system. To that, in addition, we are going to place, and we already placed some additional tenders for the replacement of further infrastructure parts. We want to replace our galleries. At the moment, we do our newsroom gallery. We are also replacing our server rooms and news studios and so on. And one part more of that is that we are faced with the centralization of our distributed audio production areas across Vienna. We had, at the moment, we have 3 different areas in Vienna, and we want to centralize them to one center in ORF Center. Can you please, yeah. three of these parts, which we call Content Management Center, and where we want to go now deeper, we can come now deeper, is the Playout Center, the main control room, and the new monitoring system. We call them CMC, Content Management Center. And on the next slide, we have already, you can show you now that the idea is already getting a little bit more than to realization. Here we have the screenshot from, I think, last week. So we are now starting to make the first transfer processes from the main control room to the new built area. And these are some videos we are now testing and trying to move the main control area to another place.
Okay, so that was the general project scope. When looking at this, it was clear that there would be several control systems required to control this. And also one additional requirement was that the different areas should have their own control system. So as you can see on this slide, we have for the playout and the master control room, two different areas, which each have their own SDN controller and broadcast controller. And furthermore, we have an overarching umbrella management system, which monitors all the operations, but also acts as a interface to existing scheduling systems for scheduled connections. The SDN controller is controlling the real-time network and the end devices, just to make the IP connections possible for the individual flows, and also handles 2022-7 redundant stream routing. And the broadcast controller does what the traditional broadcast controller does. It manages the connections. It creates association between different types of streams, like video and audio and data, and also configures parameters in the end devices. And between the two areas, at first, there is what we call the federation, so that streams can be directly routed across the two real-time networks, and sources and destinations, selected sources and destinations from the other network can be seen and switched to local sources and destinations. And you see an ellipsis on the right side of the picture, where there will be further sections added to the picture in the future. There will be galleries, ingest areas, and so on and so forth. And all these different sections will come together into one system where you can route IP streams directly between the different sections. This is a general overview. Usually people are interested in who is doing it. The umbrella management system is a Skyline data miner. The broadcast controller is an EVS Cerebrum. SDN controller is Navion Video iPath. Then we have several end devices, obviously. For the playout system, it's a channel in the box, a Pebble Beach Dolphin with Marina automation. We have Imagine SNPs for gateways, multi-viewing and processing. For the displays, we have gateways from Riedel, the Fusion 6B. We have measurement devices from Telestream, the Prism. And for stream monitoring, we have a Bridgetech VB440 in the system. Then the network consists of Cisco Nexus, at least the real-time network, and Cisco Nexus 9300, mainly as leaf switches, and 9500R as spine switches. There is also a management network, which also consists of Nexus switches with some Catalyst switches attached to it, where we need fanless switches for noise reduction. And PTP clocks are coming from Meinberg, the Landheim M3000 series as the master clocks, and the M1000 series for generating blackburst to interface with a legacy signal clocking signal distribution. So that's one step we will be taking, that the complete clocking signal distribution will be fed by the PTP clocks. Okay, so we're going to the specific requirements of audio signal management.
Yeah, we had a lot of experiences in the past where we always faced troubles when we handled video productions from a gallery to our playout center, for example, and sometimes it was the trouble caused by Dolby E, embedded or not, or maybe the number of audio channels which we could transfer via our SDI infrastructure. It was always too less, and we had to handle also Dolby E and all this timing stuff and all that stuff. We want to get rid of this now in the future with this project, and therefore we wanted to have a possibility to route different audio signals through the network. And yeah, it should be possible that the system helps the user. So we thought it might be interesting that the user is not aware of how many channels are in one stream, or how many streams are supported by the system. The system should help the user. And of course, the system should also handle Dolby E, because we have it as a legacy at the moment. And the next 5 or 7 years, we will handle Dolby E, because our old infrastructure uses Dolby E. And therefore, we said, okay, users should not know the properties of the devices. The system should handle it for them. And the system, of course, should help the user and give the information. Yeah, it is possible, or does it on itself, or gives a good what's the name? Gives a good feedback to the user why it's not possible to route these signals, because there is in an IP live environment, we are thinking about a new approach to signals and how to manage them. This means when we get live feeds inside, we want to add maybe some additional content to them. And we want to make some packages of signals and provide them to other users inside the ORF center. And therefore, we need a system which knows what is now in a package, who's owning which stream, and what's the inside the stream. And of course, we want to know who is booking my lines, who is booking the incoming lines, what are the outgoing lines, which signal should I use to enhance with my additional commentary, for example, and which signal is the distribution signal, because we have to distribute our signals to our daughter company, which is doing the distribution for us. So in a network, we have to make some virtual tags on those streams, we thought, and that is part of the solution, which will Hartmut now tell you.
Okay, in the network, we have different streams which carry different types of signals, like video, audio, and data. And we combine those streams into what we call bouquets, which are streams that are usually switched together from source to destination. In our case, we define the bouquet can hold up to 2 video, 16 audio, and 4 data streams. We used 2 videos because sometimes you still have key and fill signals, or you have a UHD video and a proxy video in, like, say, 1080i. 16 audio seems to be a lot, but we wanted to be future-proof here. Usually, we probably would have 4 audio streams, like a local and a foreign language, both in stereo and 5.1. But as Andreas already said, in the future, there might be more different audio types. And so we wanted to be future-proof here, and 4 data streams with the same reason. In each bouquet, the streams are numbered consecutively. Why that's important will become apparent later. And each source and destination is associated with one or more tags in the broadcast controller, which specifies the format and the content of the stream. I've given here some examples for stereo, German, STD, 5.1 audio 6 channels, English language would be a 5.1-E tag. We also give tags to video, and then also for data streams. So it's a uniform, although this presentation is called audio signal management because that's where it came from to handle the different audio languages and formats that were there. It also is extended to video and data streams. And why do we do that? And to show you why we're doing it, I will show you the user interface that we have created. This is a screenshot of the full user interface, and I will go into the details in a minute just to show you how it's looking. In the top, we have the sources like on a standard router panel. In the bottom, we have the destinations. On the right side is navigational buttons, but in the middle, we have the different levels because each source and destination is such a bouquet, and you can either route the complete bouquet or you can route the individual sources if you choose to do so. And this is how the levels view looks like. You have like the different names of the different levels on the source and on the destination, and in the middle, what's routed to the destination, just like you would on a standard router panel. But this is combined of video and audio in this case. And you see all the different levels, but you have also the option to shrink levels so that levels that are unused in source and destinations are hidden so that you are more focused on what you actually have. And then there is this other button, view tags. And if you enable both these buttons, then you can see that the video, which was not the second video, which was not used in this case, is gone. And you see now the tags on the different sources and destinations and see what's in the tags. If we go on looking around the user interface, we see this navigational section where you can navigate through your destination, and the same is on the sources, destination source categories by going to your home destination, move back and forth through the category hierarchy. We have also an undo button, so you can undo your last switching as long as you stay in the same panels. They are safe, and if you recognize you have done something wrong, you can undo it, which also a very cool feature. The lock is like pretty much standard functionality. And then you have 2 take buttons. One is the take button and the other is the auto take button. The auto take button is like a mode switch. Either you are in auto take mode or you are not in auto take mode. If you are in auto take mode, you select the source bouquet and the destination bouquet, and the destination bouquet is switched automatically with all the streams switched, and the components with the same tags are switched together. So the source with the right tag is switched to the destination with the right tag, even if they're not in the correct order in the order. If you switch off auto take, then you can select the individual components and then hit take when you have made the correct selection, so that you can route individual components easily. If you do such an auto take, then of course you need to have some rules how it should match. And this is the rules we have come up with. So the first rule is, if a bouquet is switched, like with the auto switch functionality on, only identical types are matched. So as you can see, the stereo German is matched to the stereo German, the 5.1 is matched to the stereo German, the stereo English, which is like on a different position on the source, is matched to the stereo English on the right side across the different levels. And you can have more of one type. Then the question is, what would that be? So since the system cannot tell a difference, it just goes on numerically. So the first stereo German is connected to the first stereo German on the destination, and the second is connected to the second. And if a receiver has no match, like there is no second stereo English, then it's disconnected. So usually it's no use having an old signal lurking around on those receivers. So then they are disconnected. If a source has no match, like this alternate foreign language, then it's not connected. Obviously, you always can make a connection by going out of auto take mode and making a manual connection across levels. The possibility to have those bouquets is not limited to one device. So if you have like your playout server and your teletext generator, then you can combine these into one bouquet and switch them together to one destination, like is shown here. Yeah, that's what we come up with. And yeah, it's really interesting to see the different possibilities of those bouquets and tags. We can also have two different tags on the set, or multiple tags on a single level, so that we can assign like a program feed besides the language, so that we know this is the audio that's really meant for a playout, and is then routed to the playout system like we have here. This is the main playout audio in stereo and 5.1 on the and a secondary sound audio for the playout. So that's for this, and yeah, actually we're finished a little bit early. So maybe there are some questions.
Yeah, we do have a couple questions here.
That's great.
First question from the audience is, having multiple SDN and BC systems for every section sounds expensive. Why not using just one for all and expand it over time?
I think I should answer this question because we had a lot of discussions, of course, ORF internal
Sure.
when we started the tender. Yeah, it was the idea how to renew galleries in future. Now, when we start everything new, of course, we can put them all inside, and for sure it will work. But our experience in the past was when we rebuilt a gallery, you often have to do some reprogramming, restarting those systems and learning some new features and coming in and out, getting an update or whatever. And therefore, you always come to the existing playing systems. You have to modify them, restart them, and they are not usable for some times during the reboot process, for example. That was the thing that we said we cannot accept this. This is our main production area, and we have to separate those installations.
So kind of like a little bit of fault or network sectionalization. You were trying to keep one thing from affecting another one that's actually live on the air. Whatever. That's pretty
exactly.
good. But was it a huge cost impact, or was it manageable?
Yeah, we can realize it, so it was possible to do it with our partner. Yeah.
Okay.
Of course, it costs more than one system, no question.
Right.
On the other hand, those systems are licensed by devices, so it's not like double the cost, because the number of licenses stays the same regardless of you have one or two systems. Of course, there is some like base price for the system, which adds to the cost, but yeah, it's not that significant. I mean, I think the cost driver is more than the consulting that's needed to make everything work together. Yeah, so that I mean, getting these things in sync and work together, and having having this federation to work across the different systems. Yeah, that's, I mean, there's something you need to do. Yeah,
it's a challenge in the project. Yeah, that's a challenge in the project. Yeah.
Well, I mean, it's always good to have something new to worry about, So the next question, let's see, we've got a bunch of them coming in here. Hold on a second. So there's a question here. It says, is ORF relying on Quest audio management solution, or SMPTE standards for vendors? And I think really what the root of the question is, some of this bouquet work and things like that. How do you see that becoming more general purpose and spreading out to other vendors and things like that?
I mean, the basic facilities in the basement are standardized.
Sure.
It's just a thing, or the matter of the controller and what is the intelligence inside the controller. So of course, all streams we use are standardized SMPTE 2110 streams.
Mm-hmm.
I don't know
if anybody else.
Yeah, ISO 4 and ISO 5 we use. So these are the standardized methods. I don't know if other vendors from broadcast controller systems or SDN controllers will adopt these ideas. I don't know. Yeah, okay. But we had some experience. We had an IP OB van, and it was our first project, which is now up for 2 years. And some of these ideas came up with these systems because we faced audio receivers or audio infrastructure which was able to keep streams with 8 channels, sometimes with 4 channels, and we tried to connect 4 channels with 8 channels, and of course it did not work. Right. So yeah, we had to find something to help the operators for for these big projects. Yeah, that's the reason why we came up with this idea. Okay,
I have another question. How do you manage the relationship between bouquets and associated tags and senders receivers capabilities? Is this a manual process?
Yeah, currently it is a manual process. So you have to define in the broadcast controller which stream has which tag and belongs to which bouquet. So currently there's not like an automatic discovery process. Obviously, we support this manual process as best as we can with user interfaces and appropriate naming of sources and destinations. But currently, it's a manual process.
But gotcha. in future, we are thinking about with our Skyline data miner possibility to have a possibility to book lines with audio and video signals from outside and to make a bouquet of them. So this is some kind of automatization for under brackets, yeah, gotcha. for a few signals, yeah.
All right, so we're almost out of time, but I see one more interesting question here. It says, what is the upper limit on the number of channels for each audio flow? If there is one.
I think in theory we said it's about 64, but yeah, we just want to be open for that for the future. At the moment we don't use this number.
Yeah.
Yeah, I think I saw 16 somewhere in the presentation, right?
Yeah, the system itself does not impose a limit. It's a question of what the end devices can support.
Yeah, exactly.
And I mean, that's what all this about. I mean, there are so many different end devices, and you can have an end device that only can receive one mono stream, and then you have an end device which can give you a 64 channel stream, and you have to try to connect these things as best as you can. And if the broadcast controller has knowledge about what the streams are and how they could connect, then it can in the future make automated decisions on how to connect, or if it needs to have an audio shuffler inserted somewhere in the signal chain.